Good evening, ladies and gentlemen. Good evening, ladies and gentlemen. I hope you can all hear me.
Yes.
Okay, thank you so much for joining us today. My name is Rosalind Nami, and I am your moderator for this session. So we are delighted to have you here for today's session. And before we start, I'll be introducing Alka to you and what the whole association is about. Okay, so in Alka, our main mission is to promote the growth of language services companies in Africa and facilitate language sharing and best practices across the continent. We have a vision also to contribute towards building a resilient and thriving language services sector in Africa. Mainly, we have objectives which include the contributing to the growth of language services companies, promoting knowledge sharing and best business practices, and creating visibility through advocacy. We were established in 2023. What Alka mainly does is to organize annual conferences, monthly webinars like this one. We have research initiatives, and we organize mentorship programs. We also do industry partnerships. So we have an upcoming conference this year for the 27th to the 28th of August 2026 right here in Accra, Ghana. It's an in-person event and we still have slots for speaker applications. So please, I have linked, let me show I've done this. I have put a link for the speaker application. Okay, I will put a link for the speaker applications in our chat so that if you're interested, you can always apply for it. So this is it. We are calling on sponsors, we are calling on speakers to come and apply for the conference coming August. And the theme for the conference is turning change into growth in the age of automation. So if you have expertise in this field, if you have knowledge you want to share with us, please do well to apply for it with the link I'll be putting in the chat. Now back to the main reason why we are here. We have our speaker for the day, who is Philip Akoda. He's the founder and CEO of Nkanda. He's a lexicographer, author, language technology innovator, and the founder of Nkanda, building digital tools for African languages. So before I go any further, I want us to welcome Philip Akoda.
Thank you, Rosalind.
Okay, Philip, please, you have the floor.
Thank you, Rosalind. Okay, it's nice to have everyone here this evening. Give me a moment. I will just share my screen shortly. Can everyone see my screen, please?
Yeah, we can.
Awesome. Okay, thank you for that introduction, Rosalind, and thank you to the organizers for the invitation. Today, I want to explore a question that sits at the intersection of linguistics, technology, and the future of African languages in AI. So we often talk about documenting our languages, we talk about preserving them, we talk about digitizing dictionaries, but in the AI era, documentation and digitization are no longer sufficient. And the real question is this: are we designing our lexical systems in a way that both humans and machines can truly understand? So this session is not about mobile apps. It's not about publishing more dictionaries. It's about infrastructure. And by the end of this talk, I hope we can think differently about what lexicography must become in the age of AI. So let me begin with a brief observation. If you spend time on Facebook or TikTok, you've likely seen AI-generated videos recreating scenes of everyday African life, village settings, market scenes, family conversations, dramatic moral stories. For example, this clip here on my screen is from Tolani Talks. This is an AI-created vlogger.
Tolani, yes, auntie, you're turning 30 very soon, no? By now, you should be thinking of getting married. When are you going to bring a man home? Until they've been to one of the rest, no go get sense. Tolani.
So what is striking is not only the visuals, but the voiceovers. They sound really realistic. They imitate African accents. Some even use Nigerian pidgin. And technologically, this is impressive. But there is a noticeable pattern. Despite African settings and accents, these videos rarely produce voiceovers in indigenous African languages. You hear English, you hear pidgin, you hear accented variations, but you do not hear Yoruba, you do not hear Twi, you do not hear Ndebele, or many other indigenous languages rendered fluently at scale. So the question is this.
Tolani, yes, auntie, you're turning 30 very soon, no?
Is this a limitation of technology or of data infrastructure? AI systems do not exclude languages intentionally. They generate outputs based on the structured data available to them. So if a language lacks large, well-annotated corpora, structured lexical systems, phonological encoding, morphological modeling, it becomes computationally invisible. So when I ask, is your language AI ready? I'm not asking whether it has speakers, I'm asking whether it has infrastructure. In the AI era, visibility is determined not just by population, but by structured data. And that is the problem space we are entering today. So have you ever wondered how Google Translate works? You see, Google Translate relies on neural machine translation. Think of neural machine translation as a large, complex model that learns to translate by analyzing millions of sentences. It doesn't translate word for word, but understands the meaning of entire sentences. For low-resource languages like Yoruba, Igbo, Kikuyu, Google's primary method for gathering training data is to crawl the public web to find these unstructured translated sentence pairs. But because these languages lack the extensive parallel text that power high resource translations, Google's system relies primarily on monolingual data, text in a single language scraped from the public web. So this unstructured data come from sources like news websites, blogs, and international reports where the language appears, even without accompanying translation. So let's talk about different types of data out there. We have unstructured data, we have structured data. And unstructured data is raw, noisy text mined from the public web, such as social media and messaging, PDFs, news articles, academic papers, product reviews, etc. And we also have one thing about unstructured data too, is that it's the foundation for most training data because it is in abundance. It allows the model to learn the general vocabulary, sentence structure, and flow of a language. And the model identifies statistical patterns by processing massive amounts of this noisy web text. So structured data, on the other hand, is often known as the refinement layer because structured data is clean, curated, and often manually created data sets. It is used to fine-tune translation models, and it teaches the model specific rules. For example, in Yoruba, it could teach it how to correct tone marks, handle cultural nuances, and even enable specific features like voice recognition, especially using transcribed audio. So I'm using Yoruba here as a case study, just so we have an understanding of how Google gets its structured data, how it sources its data, and how we see the finished product. We see the translator producing translations. So Google translates training data for Yoruba comes from several key structured sources developed through research partnerships and academic collaborations. We have here the Waxal project launched in early 2026. It provides over 1,250 hours of transcribed natural speech and 20 plus hours of studio quality recordings for Yoruba. And it's developed in partnership with African universities, including Makerere University and the University of Ghana. We also have the Tata dataset, that's the table to text in African languages, which contributes nearly 9,000 examples where tables and charts are paired with human written descriptions in Yoruba, helping the model learn to generate fluent text from structured data. Then we have the Menu 20K corpus, created by academic researchers, and it offers a multi-domain parallel corpus with carefully curated orthography, including proper diacritics for Yoruba to English translation, which has been shown to outperform Google's baseline by plus 87 BLEU scores in benchmark testing. So these structured resources complement the vast unstructured web data out there, the news articles, the blogs, the reports, all of these that provide the foundational skill for training, with the structured data serving as critical refinement layer for improving accuracy, handling tone marks, and enabling voice-based features. Now that we have an understanding of how Google Translate and other similar translators work for low resource languages, let's dive into the topic of the day, lexical systems, or designing African lexical systems. So when I use the term lexical system, I do not simply mean a dictionary. A dictionary is a product. A lexical system is more of an architecture, which generally refers to a structured collection of lexical items, words, phrases, and their relationships. A lexical system encodes words, their meanings, their grammatical behavior, their phonological structure, their semantic relations, derivational histories, and dialectal variants, among others. In other words, it captures how meaning is organized within a language. Now, traditional lexicography has done this work for human readers. A human can infer relationships, a human can interpret tone in context, a human can resolve ambiguity using world knowledge, while machines cannot. For a computational system, a lexical system must go further. It must make explicit what humans infer implicitly. For example, if two words are semantically related, that relationship must be typed and structured. If a word is derived from a root, that derivation must be encoded. If tone distinguishes meaning, tone must be represented as data, not decoration. A machine does not understand a language, it processes structured representations of that language. So when we ask whether a language is AI ready, what we're really asking is, does it have a lexical architecture that machines can parse, query, and reason over? This is where the shift begins, not from language to AI, but from dictionary to system. So before we talk about redesign, we must first acknowledge foundation. And I think this is a very critical topic that a lot of organizations don't talk about much. African languages did not arrive at this moment unstructured. For many languages, especially in the natural language processing space, lexicographic traditions played a central role in stabilizing written form. Dictionaries, grammars, and orthographic conventions shaped how words were standardized, how tone was represented or not represented, how meanings were documented, how literature was produced and taught. In many cases, lexicographic work supported the emergence of written literature and formal education systems. And we see that if we go into history, where very often it was either missionaries or anthropologists that set the groundwork for the first language resources in a lot of languages across Africa. And these tools, they were not merely reference tools, they were acts of intellectual infrastructure. They were designed for a particular context, human readers, print culture, pedagogical transmission. It is important to understand this historically because the goal was clarity for human interpretation, not machine parsing, and that distinction matters. Because when we now discuss AI readiness, we are not critiquing those traditions. We're recognizing that the technological environment has changed, the design constraints have changed, and lexical systems must respond to these new constraints, just as earlier scholars responded to the demands of literacy and print. One of the most consequential design decisions in many African lexicographic traditions concerns tone marking, especially those that are written using Latin alphabets. What is tone marking? So if you look on the slide, you'll observe some marks on the first two words in the Yoruba sentence. Those marks are called tone marks, and tone marks are used in writing to represent the pitch of a syllable. They help a person know the difference between ba and ba. In a tonal language like Yoruba, these marks are not optional decorations. They are a crucial part of the spelling of a word, just as important as its consonants and vowels. And it's important to note that the majority of African languages are tonal, including Yoruba, Hausa, and several others. A number of notable non-tonal languages in Africa also exist, including Swahili, Wolof, and Fula. But nevertheless, the choice of indicating tone marks was one of the most important decisions in the writing culture of many African languages. Languages such as Igbo, Hausa, and Efik, as well as Twi, they do not include tones in their conventional writing system. However, the choice to include or exclude tone has computational consequences. When tone is consistently marked in writing, lexical ambiguity is reduced at the orthographic level. When tone is also conventionally omitted, ambiguity must be resolved through context, something humans do effortlessly, but machines struggle with it unless properly modeled. So the issue is not whether one tradition is superior. The issue is that orthographic conventions determine how meaning is encoded in text. And computational systems depend heavily on what is explicitly encoded. In other words, historical writing conventions shape modern machine interpretability. That is why orthography is not just a cultural artifact. It's a design philosophy with long-term structural effects. This becomes clearer when we look at a concrete example. Let me illustrate this with a concrete example from our work at Nkanda. Hausa is a tonal language, and tone is phonologically meaningful. It distinguishes lexical items and can affect interpretation. However, in conventional Hausa writing, particularly in literature and everyday use, tone marks are generally not represented. Without the accented word column you can see on the screen, we cannot tell the difference between the two words. The first being pronounced as makaranta, that's a school, and the second as makaranta, which is a scholar. In lexicographic contexts, tone may appear, but in novels, essays, and most written materials, it is typically absent. And for human readers, this is not necessarily problematic. Speakers rely on context, world knowledge, and familiarity with the language to disambiguate meaning. But computational systems do not have that intuitive, interpretive capacity. When tone is absent from the surface form, lexical ambiguity increases. So in designing the Hausa lexical database within Nkanda, We made a deliberate decision. Every lexical item includes a tone marked equivalent, not as ornamentation, but as optional metadata, but as structured phonological information as well. Tone is encoded systematically so that it can be processed computationally. This does not alter the literary tradition. It does not impose tone marking on everyday writing. Rather, it recognizes that orthographic conventions were designed for human readers, while lexical databases must also serve machine interpretation. In other words, historical writing practices remain intact, but lexical infrastructure must reinterpret them under computational constraints. And that distinction is central to designing AI-ready systems for African languages. From here, we can expand this logic beyond tone to structure more broadly. When we think about African lexicography today, we're often operating within one of three design paradigms: documentation, digitization, or system design. Documentation is the foundational stage. It is about recording language and collecting words, defining meanings, preserving usage, and often producing printed dictionaries or grammars. Digitization is the next step. Here, documented materials are made accessible electronically. And lastly, we have system design. At this stage, lexical data is organized intentionally so that both humans and machines can use it effectively. So let's talk about documentation. What you see here represents documentation, a traditional dictionary page. This format reflects decades, sometimes centuries, of lexicographic scholarship. If you'll notice its structure: alphabetical organization, headword, part of speech, definition, sometimes example sentences. And this format is highly optimized for human use. A reader can scan the page visually, interpret abbreviations, infer relationships between entries, use contextual reasoning. But from a computational perspective, this structure is largely implicit. The relationships between entries are not formally typed. Derivations may be described, but not encoded as structured links. Tone may appear visually, but not as machine-separable phonological data. And the design assumption here is clear. The interpreter is human, and that is entirely appropriate for its historical context. But documentation by itself does not automatically translate into machine-readable architecture. And that distinction becomes clearer when we move to the next stage. That's digitization. So what we see here is digitization, the same or similar lexicographic content now available electronically. It may be searchable, it may be downloadable, it may be accessible globally within seconds. And digitization improves access dramatically. It removes physical barriers, it increases distribution, it supports preservation, but structurally, very little may have changed. If this is simply a scanned PDF, the internal relationships remain implicit. Even if it is searchable, the search is often string-based, not relational. The machine can find character sequences, but it does not necessarily understand derivational structure, semantic hierarchies, morphological composition, phonological features. In other words, digitization changes format, not necessarily architecture. And this is an important distinction because in many discussions about African languages and technology, digitization is treated as the end goal. But from a computational perspective, it is often only an intermediate stage. To understand what I mean, we need to look at the next level, that's system design. Now we move from format to architecture. What you are seeing here is not simply a dictionary entry displayed digitally. It is a structured lexical entry. If you notice the difference, each lexical item is not just a word with a definition. It has a unique lexical identifier, structured definitions, example sentences tagged to specific senses, explicit semantic relations, derivational or morphological links, phonological data represented systematically, dialectal or variant metadata where relevant. And this is no longer a page, it is a node within a relational system. The relationships between entries are not implied, they are encoded. If a word is derived from a root, that connection is structured. If two words are semantically related, the relation type is defined. If tone distinguishes meaning, it is represented as data, not just typography. This design assumes a different interpreter, not just a human reader, but a machine, a system that can query, traverse, and compute over relationships. In other words, documentation describes language, digitisation distributes it, but system design models it. And modeling is what computational systems require. From here, we can begin to think of lexical entries not as isolated definitions, but as interconnected graphs. Traditionally, dictionaries are lists, alphabetical, linear, sequential. Even when digitized, they often remain lists. But computational systems do not process language as lists. They process structured relationships. So we need to reconceptualize the lexical entry, not as an isolated unit, but as a node in a graph. So what does this mean? It means every lexical item connects outward to its root, to its derived forms, to its semantic neighbors, to antonyms and synonyms, to dialectal variants. And each of these is not just text, it's a typed relationship. When these relationships are explicitly encoded, the lexicon becomes navigable, not just readable. Now, here is the important shift. If you hyperlink a root word in the etymology field to its own lexical entry, you are already thinking graphically. That hyperlink is not cosmetic. It formalizes relational structure. And once structure is formalized, machines can traverse it. So it's important we ask ourselves, are we building word lists or are we building lexical networks? Because one feeds documentation and the other feeds computation. In the process of building African lexical systems, data you will assume might not be relevant to machines might actually be essential. For example, word formation and morphology. This is a critical aspect of linguistics, but is often left out in digital designs of dictionary databases, and perhaps not even prioritized enough in other language projects. If you accept that lexical entries are nodes in a graph, then morphology becomes central. Many African languages are morphologically productive. Words are not static. They are formed through affixation, reduplication, compounding, which is the uniting of two separate words. We have tone modification, derivational processes. And if you look on this slide, you observe that the etymology of the Yoruba word afagi has been provided. Some of the words in the etymology are colored green to indicate that there is a hyperlink in the field. This hyperlink connects one entry to another. Let me emphasize this. While computers can learn concepts like compounding through parallel corpus, intentionally teaching machine word formation processes can greatly improve computational abilities, such as automated translation of films. If a system understands the rules behind word formation, it can interpret words it has never seen before. But if it only memorizes entries, every new word is treated as unfamiliar. Next, let's look into phonological representation, because for tone languages especially, sound is structure, or rather dialect continuum. Many African languages do not exist as a single, neatly standardized systems. They exist along dialect continua with phonological, lexical, and sometimes syntactic variation across regions. Have you ever wondered if you speak Ashanti Twi, you'll sometimes realize that you can understand Fante because both languages are mutually intelligible. And sometimes you'll notice that if you speak Zulu, you somehow are able to navigate Xhosa. The answer is simple. Your brain doesn't just memorize word combinations, it understands abstract linguistic rules like grammar and sound shifts. And when you hear a dialect, your brain intuitively maps these variations back to the standard form you know. The temptation in lexicography has often been to select one prestige or standard variety and marginalize others. Computationally, that approach is limiting. For languages such as Igbo, this is also impractical. If we collapse dialectal diversity into a single flattened standard, we erase variation that could otherwise be modeled systematically. A better approach is architectural rather than political. Design lexical databases where entries can store dialectal variations, where entries can store dialectal variations as structured attributes. Instead of treating dialect forms as noise, we encode them as related nodes, variants of phonological shift of using certain terms to connect dialects to standard forms. And this allows machines to learn correspondences across varieties rather than treating them as unrelated tokens. In languages with shared phonological systems across dialects, phonology can even become the unifying layer that connects surface variation. The goal is not forced uniformity, but structured interoperability. If we design our lexical systems carefully, dialect diversity becomes computational strength rather than fragmentation. Designing machine-readable lexical systems cannot be done by linguists alone, nor by computer scientists alone. Linguists understand morphological systems, tone behavior, semantic fields, and dialect variations, while computer scientists understand database architecture, graph structures, data modeling, and algorithmic optimization. When these disciplines operate in silos, the result is either linguistically relevant, elegant resources that are computationally unusable, or technically robust systems that lack deep linguistic structure. True progress requires institutional collaboration, especially between departments of linguistics and departments of computer sciences, particularly across universities in the world, across Africa and other parts of the world. Joint research labs, shared data sets, co-supervised thesis, and interoperable standards can transform isolated projects into scalable infrastructures. If structured lexical systems are to power artificial intelligence, they must be conceived at the intersection of linguistic theory and computational engineering. At Nkanda, we are attempting to operationalize many of the principles previously discussed. Our work focuses on structured lexical system design rather than static documentation. Each word in our database includes clear definitions, example sentences to show usage, indigenous audio, semantic relationships, and links to related words. Where tone matters, we represent it carefully. Where dialect variation exists, we account for it. The goal is not merely to build a dictionary, but to develop structured lexical databases that are designed to be useful not only to humans, but also to machines, not only to readers as well, but also to researchers and technology developers. While currently building our third database, which is the Hausa Dictionary database, and which at the moment consist of over 15,000 words. We are also working towards increasing the number of example sentences per word and aligning these sentences with audio recordings. This will allow us to connect written language with spoken language more effectively. The long-term aim is to create a language resource that supports education, research, and future AI systems. And this is still evolving, but it reflects a deliberate effort to move beyond simple digitization to organized, usable, and linguistic data. Most lexical projects operate at the level of a single language, institution, or grant cycle, but AI operates at scale. If African languages are to compete for visibility in global AI systems, isolated efforts must evolve into interoperable frameworks. A Pan-African lexical architecture would not erase linguistic diversity. It would standardize structural principles, shared metadata, schemas, conventions, relational tagging systems, phonological encoding standards, and morphological modeling. Such interoperability allows datasets from different languages to speak to one another computationally. Strategically, this moves African language work from preservation mode to infrastructure mode. It reframes lexical databases as continental assets rather than isolated academic outputs. We began with a simple question. Is your language AI ready? Not in terms of number of speakers, not in terms of literary history, but in terms of structured machine-readable infrastructure. Does it have relational lexical databases, encoded morphology, modeled phonology, interoperable metadata, annotated corpora? If the answer is no, the language risks computational invisibility. If the answer is emerging, then this is the moment to scale deliberately. The AI era will not wait for linguistic preservation cycles. It will privilege structured data. The responsibility before us is not only scholarly, it is infrastructural. I leave you with this food for thought. The future of African languages in AI will depend less on admiration for our cultural richness and more on the rigor of their modeling. Thank you. I hope you enjoyed today's session. If you have any questions, I'll be happy to take them.
Thank you very much for an insightful session, Philip. We are so grateful. We truly appreciate the knowledge you shared with us. I'd want to know if we have any questions for Philip before we continue, please.
Yes,
So there are no
Adi.
questions in the chat box. Okay, yes. Please, is anyone speaking?
Yes, thank you so much, Philip, for the presentation. It was great. So I wanted to find out about the I know with African languages there's a lot of controversy at times in terms of even the writing systems. And so I want to find out, you mentioned collaboration and you mentioned collaboration and universities, but I want to find out who are the stakeholders in deciding on this the standard. For instance, if a language needs tonal marks, because some languages may have it, but they will choose not to use these tonal marks. Like you give the example of Hausa, for instance.
Yeah.
So, like, who are some of the stakeholders, and do you have examples of, situations where or languages where the stakeholders were able to work together to make this thing work out properly? That's my first question. And the second one is, what is the name of the app? Because I was searching for Inkanda, I couldn't find it. So for people that are searching for it, maybe you can just share the name in the chat or something. Yeah.
Okay, I will drop that in the chat. Okay. So let me just write that down. The second one. So regarding your first question, The thing about orthographic rules and how we write, especially in a lot of languages which I would regard as privileged, and I regard them as privileged because these were languages that were prioritized when the missionaries, the colonialists and early anthropologists came to Africa. So for a lot of African languages, when the missionaries arrived, when the anthropologists arrived, they did quite a lot of documentation on our languages, and they were the ones who made these decisions. For example, the decision to use tone marks in Yoruba was made by Reverend Samuel Ajayi Crowther. That was in 1843, and he made that decision in the Yoruba dictionary. And because the lexicography was the foundation, the Yoruba dictionary was the foundation, it influenced other works such as the Bible, the literary texts, exercise books, textbooks, etc. And this was also the same for Hausa. And the thing about the decisions that they made was that these scholars, because many of them were largely scholars, they were trained in linguistics, and they made these decisions based on a number of factors, such as was it going to be convenient for the speakers? Does this language have too many tones that it's necessary to actually have it represented, or would too many, because of its numerous tone marks, perhaps we should leave out the tone marks so that people would not be confused, because were certainly some of the decisions that had to be made. So for Hausa, for example, they realized that it did not have so many variations of words as with Yoruba. For Yoruba, you can have one word with the same spelling but different pronunciation. At least you can have, take for example, you can have a share, you can have a se, you can have a se. So it's like the tones basically for each different pronunciation, it has a different meaning. And because of that, the pioneers of the orthography thought it wise and realized that it was more strategic and it would represent the language better when tone marks were used. So the decision on whether tone marks are used or not used are actually made by language committees in different countries. If you investigate into the educational curriculum of a lot of African languages, you'll realize that there are language boards that are in charge of the orthography. There was a language board in charge of the Akan cluster of languages, for example. You'd have the language board, I can't quite remember the year, but the pioneers, the language committees decided on whether there would be tone marks for the Akan languages or not. And we see these decisions everywhere. At the time when these decisions were made, they did not take into consideration, I'm sure they would never have thought that computers would be around. So the decisions were mainly made to cater to the needs of the language and the needs of the people. So I hope that answers the question. Although you did talk about stakeholders in the space, could you just circle back on that, please?
Yes. So yes, I know there are language commissions, linguists. So I think these are the stakeholders, right? I wanted to know if there are more stakeholders, maybe computational linguists as well. Okay.
Mm-hmm. Yes. So yes. I think in this day and age, there are definitely more stakeholders. As a matter of fact, I would say one of the stakeholders which are often not given top priority or basically undervalued are those in the literary circles as well. Because I would say when many of these languages, the orthography was established, it was not just lexicography, it was not just dictionaries that were developed, but the language remained relevant as long as those in the literary circles kept on writing and producing literary works for these languages. And over time, we're not seeing so many literary works in indigenous languages as before. So it's we would say language technologists, those in the literary space, and computational linguists, lexicographers, etc. So these are some of the stakeholders in that space. Okay, yes, you can go ahead, Sifo.
Thank you. Greetings. I'm Sipo from Zimbabwe. I've been following you for quite some time, especially if you still remember after working together on that Ndebele project. But this has been, an opener of a presentation, especially on issues what you presented on. And as you were presenting rather, I was just reflecting on our own languages here in Zimbabwe. And I realized, especially on those three stages you presented on documentation, digitization, mostly for our languages. I think we only have Shona, which is a bit better when it comes to documentation, but for Ndebele, Tonga, and other languages, we are still lagging behind when it comes to documentation. We have universities, teaching those languages as modules, and students even struggle when it comes to researching. They can't even find hard copy dictionaries. So now I'm imagining if we are still lagging behind when it comes to documentation, how about on the computational linguistics of it? And we it's I think it's high time as linguists we take up the role ourselves and we start doing the work on our own instead of waiting for the white men to come back, and do it for us, because they might never come to save us. So I thank you so much for this. And I take it as a challenge, to say it's high time we ask that question you asked us. Our language is ready, to actually for the age which we are living in, and we cannot run away from computational linguistics at this point. So thank you so much.
You're welcome. And thank you for joining this session too. I do remember the Ndebele project we were working on.
Yes. A reminder about the name of the app, if you can write in the chat, Philip.
Yes, I'm about dropping
Thank
that
you.
in the comments.
Okay. Please, is there any other question? All right. Okay, so I'd like to thank Philip once again for such an very inspiring session. We learned a lot, so very heavy and loaded with information. And I would want to remind all of us once again about our call for speakers for our conference coming up in August. I've left the link for application in our chat box, so please do well to apply. If you think you're up for it, or if you know someone that will be up for it, kindly send the link to the person. So once again, we thank you all and appreciate you for your time and engagement, and we look forward to seeing you at all future ALCA events. Thank you so much and have a wonderful day.
Sorry, I'm still trying to drop the link
Yes,
here, please.
we're waiting for
Okay. C4 has raised his hand. C4, you can go ahead as well.
Okay.
Yeah, I just wanted to indicate that I'm not seeing any link from my end. I'm not sure that it
Yes,
has been sent on.
I'm working on it. I'm having some network issues here.
Oh, okay.
Okay, so you were saying you can't see the call for speakers link. Is in the chat. So there is a chat down below, chat icon. You click on it and yes, it's there. It's on the right.
Okay, I've dropped the link on the Play Store. That's the App Store link.
Okay, the link is in.
And that's for the App Store. And I'm dropping the Play Store. Okay.
Okay. All right, so the links for the Apple Store and Google Play Store are both in.
Okay, so I've also dropped our website if for anyone who'd like to see the work we've done over the years and our ongoing projects.
Okay, thank you so much. Thank you so much, everyone, once again. Have a wonderful evening.
All right. Okay. Thank you, everyone.
Thank you. Bye.